So welcome to this session. So this is the second part of our JupyterLab series. So this part is called Exploring and Analyzing UK Biobank Data Using Jupyter Notebooks. So just to introduce myself, so my name is Ted Vladeris. So I'm a principal scientist and bioinformatics trainer.
And my name is Anastasia Sadlakova. I'm senior community engagement scientist focused on UKB.
Yep. Great. And Anastasia is going to be, we're switching roles. So I'm going, she's going to be the Watson to my Holmes this time. She will be asking questions and slowing me down because that's a good thing for teaching. So let's talk about our agenda today. So last time we basically kind of came into, we talked about what JupyterLab. So this time we are going to be talking about Spark JupyterLab in particular and how you can use it to explore the phenodata. And then we'll do a demo and then we'll do a wrap up. So before we get started, these are kind of late breaking updates. So there have been a few updates to the JupyterLab's interface, but these are all good things, I promise. The first is we showed you in the last session, we showed you kind of how to create a notebook in the project storage using that menu item. There is now a item in the launcher that allows you to create a notebook using the DNAnexus project, the wrap project storage directly. And so this is kind of a little clue to note that your notebook is shared in project storage. There's now going to be this little DX prefix to the notebook. So this is basically like your little clue that your notebook is in the actual wrap project storage. And so you do have to remember to save it, but when you close it, basically that work is not going to be disappear. Another feature that's been added that might be useful. So if you have created a notebook on the Jupyter instance storage, you can drag and drop it. So you can basically take that tab right here and you can drag it directly into the project storage and it will be uploaded after you drag and drop. Okay, so those were kind of some late-breaking features. So let's get into the learning objectives for today. So by the end of the session, you should be able to explain the difference between a single JupyterLab instance and a Spark JupyterLab cluster, explain the basic structure of the wrap dataset, in particular the phenodata. So we'll access and manipulate wrap data and cohorts using the DX data package with the Spark JupyterLab configuration, and then articulate possible further Spark enabled analyses. So this is the TLDR. I know you are all busy, so this is kind of the summary. First, so Spark is a technology that enables you to query very large data sets by splitting the data among worker nodes. Spark jobs are directed by the driver node in a Spark cluster. DX data is our Python package that enables access to the wrap data set in Spark. Currently, this is just the phenodata right now, but the geno data is also going to be available later. UKB datasets have entities and entities have fields. We'll talk more about this. The main method you're going to be using in DX data is this retrieve_fields method. So it'll allow you to retrieve data as a Spark data frame, and then your Spark data frame can be converted over to a Pandas data frame. And again, we do want to point you to this link in our GitHub repo called OpenBio, and this has basically instructions on how to do all of the things that we do today. We'll be sending out an updated notebook that has kind of the extra bits that we'll be going through the little tour, but this covers almost all of the functionality that you need to know to work with the phenodata. So let's just kind of orient ourselves. I just want to kind of let you, get you kind of familiar with the idea of a Spark cluster. As mentioned in the nomenclature, so it is a cluster. So it is when you're requesting a cluster, you're actually requesting multiple machines. And these machines have two kinds of roles. So the first is there's only one of these, and that's called the driver node. And so this basically handles a lot of things like distributing the data to the individual worker nodes. So these worker nodes are why Spark is very efficient, and it works. It is what's called scalable. Is that what's going on is that the driver node is distributing or scattering the data to the individual worker nodes, and these individual worker nodes basically work on their portion of the data. So one thing to keep in mind is that this is not you don't get this for free. Like your software has to be Spark enabled to actually take advantage of this. Otherwise, you're not actually using the power of Spark. Today, we're going to be working with the DX data package, and that is Spark enabled, and you'll see how that kind of works. So once the workers are done with their work, basically the driver node can collate the results from the workers, and then you can get results, graphs, reports, and tables. So in our case, we are going to be querying the pheno data, and our end result here is going to be basically a table of the fields that we're interested in. And if we are interested in particular cohorts, we can retrieve basically the table for those particular cohorts.
Ted, can I ask a question about the data distribution? So looking at the schema, can you clarify whether the data are like in different table and each table get distributed to different Spark worker node, or the data are just like sliced and then distributed?
Yeah, so these are, underneath it all, there is this kind of abstraction that we're going to be talking about, which is the data set. These are actually little slices of the data set that get distributed to each of the worker nodes.
I see, thanks.
Thanks for the question. So we talked about starting up the JupyterLab configuration. I want to highlight basically the Spark JupyterLab configuration. When you basically start up the Spark JupyterLab configuration, you will be setting kind of these other features that we covered last time, such as the environment name, the associated project on wrap. And so the first thing you will be setting here is a priority. The most important thing you need to know is that when you're setting up this cluster configuration is to first choose the Spark cluster configuration here. Once you've selected that configuration, you can select the number of nodes. And then there are additional features, which Anastasia talked about last time, including hail and glow. And then there is a variant that we called hail and VEP. So these are kinds of different versions of the software. So once you've set those, we recommend then setting your instance type, because this will be reset if you to the original kind of configuration. So you can set your instance type here. In general, you want to try to use at least 16. I find that using at least 16 node configurations are good here. And then you can set your duration as before. So this is the amount of time that your JupyterLab configuration is available. And then once you have set all of that, you can click Start Environment to start the environment up.
Can I, even though like I was lecturing about the features, can I still ask a question?
Sure.
So with a single node JupyterLab, I understand the features. It was like R, Python, Stata, machine learning. But here I just want to make some more sophisticated cohort queries. And I don't understand what is Hail or Hail and Web. So what do you recommend me to choose?
So in general, so unless you're going to be working with like the genomic data and kind of for the large cohort, the DX data package is available in all of the different configurations.
Okay.
So it's mostly if you need to kind of do the kind of genomic processing with those different frameworks.
Okay, I see now. Thanks.
So let's talk about the DX data package. So this is the main way you are going to basically access the pheno data, and it will let you basically connect to the RAP data set with your Spark Jupyter notebook. So this is an internal Python package that lets you access the RAP data set. It is installed in both the JupyterLab and Spark JupyterLab configurations. We mostly use it in the Spark JupyterLab configuration. So it lets you basically, like I mentioned before, it lets you access and query the UKB data set and cohorts in Spark JupyterLab. And what it lets you do is basically and we'll go over this in detail. So you can provide a list of field names and you're potentially a cohort, and basically it will let you retrieve all of the field names within that cohort as a Spark data frame. So this Spark data frame is basically distributed among all of the worker nodes. So you can query it using Spark SQL. It's relatively quick for very large data sets. You can also convert it to a pandas data frame if that after you've done kind of filtering and you want to make it available as a CSV file. So you can do any sort of kind of manipulation that you want, such as filtering or data transformation in pandas, if that's what you're really comfortable with. And again, so these are kind of two links. And thank you, Maria, for posting the link to the Open Bio. So this is like the main notebook that we've kind of prepared for you to take you through the basics of working with DX data. But there is an additional notebook here that is also an Open Bio called Getting Started with DX Data, which covers much more the DX data package in much more detail. So just a quick review about the UKB data. So again, remember, like, when you're applying to UKB data, you're applying as with an application, and you are requesting a set of fields. And so when you are kind of accepted, basically your application is going to have an associated application ID. So this is a unique identifier that is associated with your UKB application. And again, that application ID is the controller of which fields are accessible to your application. Your EIDs, so within an application, your EIDs are unique to that particular application. And you cannot basically take a table that is kind of generated within an application and use it in another application, because the EIDs do not map across applications. And this has to do with the pseudonymization process. And this is kind of a requirement of accessing the data. So let's talk about the RAP data set. So so we talked a little bit about the bulk files and the RAP data in the overview. So the RAP data set, this is currently this contains all of the pheno data that you need to access. So all of the data that is associated with a particular participant that is basically anything that's phenotype based. So there are kind of three levels that you kind of need to be aware of. So the first is the dataset level. So the dataset, basically, this is kind of the abstraction. And again, this dataset is associated with your particular application ID. And we'll show you kind of a little recipe for accessing the dataset in Spark JupyterLab. So within that dataset, it contains entities. So entities, you can think of them as the equivalent of a table, except they can be distributed, the data can be distributed among all of the different worker nodes. So within that particular entity, the main one we're going to be using is the participant entity, which contains the majority of the pheno data. There are some other associated entities as well. So this table basically contains the equivalent of columns. In our parlance, they're called fields. So each of these fields basically has a lot of metadata associated with them. And the ones we're going to be using are title and name, and there's lots more metadata. And just to keep in mind is that fields, if they're categorical, they can have a coding. Since they're stored underneath as kind of numerical values, there's a coding that maps those numerical values to the actual categorical values. So let's go through a quick example of selecting so we're interested in selecting gender and age. So we can basically look at UKB Showcase and we can get, the particular information for our field. And each field again has a title and name. So the title, this is the title that is displayed in places such as Showcase or the our Cohort browser. The name is the actual name of the particular field in our entity. So we've got a field here. This is our gender field. The name that we need is P31. And again, we can get that from UKB Showcase or from Cohort browser. We can see that field belongs to the participant entity, and that participant entity belongs to our data set. And we'll be going into this in much more detail in a second, but I just want to set the stage. So if we want to basically, if there is a field and a cohort, and we want to retrieve only those participants in the cohort and that field information, we will need this additional bit of information, this cohort. So you can build this cohort using Cohort browser. So this is basically what it does is basically acts as kind of a filter for the data set. So it only returns those participants in that cohort. So just to kind of make you aware, so when we are working in the Spark JupyterLab configuration, there are two main kinds of data frames that we are working with. So the first type of data frame you may be familiar with, which is the pandas data frame. So keep in mind that the pandas data frame, this only kind of is loaded into the memory of a single machine. In our case, for the Spark cluster configuration, that's going to be the memory of the driver node. If we want to take advantage of basically, the processing power of Spark, we need to work with the data in the Spark data frame format. When we retrieve the fields for this, for our data set, by default, it will be retrieved as a Spark data frame. And you will see that we can do lots of different kinds of ways of kind of transforming the data using Spark. And we can basically use like the power of all of the worker nodes to do this kind of processing. So just to orient you in terms of everything. So when we kind of come in and we want to kind of query the pheno data, the first thing we need to have is a list of our fields of interest. So once we have that, we can basically retrieve all of these fields from the pheno data as a Spark data frame. We can take advantage of the power of Spark to do some additional filtering and processing. When we are kind of comfortable with the data in that format, we can convert it into the pandas format and then do additional filtering and processing in the pandas data frame format. So just this is just a quick reminder of the field name notation. So again, you know, basically all fields kind of have this particular kind of naming scheme. So it starts with P and then the field ID. And if there are instances, associated with that field ID, such as for like multiple visits, they will have this I. And if there are multiple measurements associated with a particular instance, they'll have this A. They'll have this A naming convention. So again, this is kind of an example that takes you through blood pressure measurements. So this is the very first blood pressure measurement during the initial assessment visit. So that means that because it's the initial assessment visit, it's labeled as instance 0. And then the very first measurement is going to be array 0. So again, we want to point you to the documentation. If I forgot to mention it, these slides will be available to you. So let's talk about the workflow for extracting information from a cohort. So this is not currently available in that notebook, but again, we will be sharing an updated version of the notebook that has all of this information available for you. So the first thing you're going to need is the following. We're going to need our dataset ID. You don't need to have this on hand. We actually show you a little bit of code that finds this for your project and application automatically. We'll need to have, if we're working with cohorts, we need to have the path of our cohort. So here we have an example here, it's called female_cohort. Like when I organize things, I tend to put things, have a naming convention for the folders I work in. So I'll have a folder called cohorts. So I access this by cohorts/female cohort. We're going to need to have a list of names. The last thing we'll need are one of two things. So a list of the field names for the fields we're interested in. So in our case, remember, these are the actual kind of ways that we refer to the actual fields or columns in our participant table. So this would be, we could use either P31, or if we have a list of field titles, we'll show you some recipes for accessing those field titles. So basically, if you had one for gender, you can use basically the name sex. So this is a lot on a single slide. Please don't worry, we'll go through this a couple times, but I just want to kind of talk you through the basic workflow for extracting information from a cohort. So the first part is always going to be the same. This is a little bit of prologue code, and we'll go through that in just a second. That basically lets you connect to the Spark data set and basically connect and do some Spark initialization that you need to do. Then we will basically access the dataset structure using the load_dataset function. From that data set, we'll extract the participant or the entity of interest, which in our case is participant. We'll also load in our cohort information using our load_cohort method. We'll list all of the desired field names, including instances and arrays. We'll retrieve the data as a Spark data frame using this retrieve fields method. So this is kind of the main thing. So we basically are setting everything up to basically get to this step 6. So we are Once we have this, basically we have the pheno data in the Spark data frame format. If we need to, we can convert the data to a pandas data frame using the toPandas method to do further analysis. And then we can save the results as a CSV file to JupyterLab storage. Once we're done with that, remember we need to upload it back into our UKB project using DX upload. And again, so for our users, we do recommend that you basically utilize this, or you can also use Table Exporter to basically produce a CSV file for your downstream analysis in R. So let's go over the individual bits of the code. So this part of your code is always going to be the same. So let's go over through each of the sections. So just think of this as code that should always be at the front of your notebook. And it just gives you everything that you need to access the UKB dataset in Spark JupyterLab. So the first thing we're going to do is we're going to basically import the libraries that we need to interact with the data. In particular, we need to import PySpark and our DX data package, but we will be we'll be using these other packages, the DXPy package and the pandas package as well. So the first thing we need to do is we need to initialize Spark. So this bit of code is always going to be the same. And so you only want to run this code cell once. If you accidentally run it twice, Spark doesn't like to be initialized more than once, but we'll show you how to recover from that. Finally, this last little bit, it basically is always, again, this is always going to be the same, and this will find the particular data set ID that is associated with your project. And we'll be using this in just a second to actually connect to our data set structure. So now that we have that dataset ID, that dispensed _ dataset ID, we can now load our dataset structure in using the dxdata .load _ dataset by passing in that dataset ID. And then we can extract the participant data structure using basically the bracket accessors. So we'll use dataset, bracket, and then participant in quotes and bracket to extract our participant entity.
So Ted, can I ask about the entity,
Sure.
the questions? So you say that for phenotypic data, we'll be using participant entity, but how do I know, like what entity should I use for my fields?
Yeah, so in general, like, basically looking at UKB Showcase should give you more information about the particular entity. So for example, entities such as hospital visits will begin with HESIN, and then it'll be followed by _. And then entities associated with GP visits start with GP.
Oh, okay, thanks.
So once we've basically we're starting to set the stage again. So we need to basically access our cohort data structure using load _ cohort. And we'll use as input basically that path to our cohort. And you can see that we have this, we always start with kind of the root folder, so that / cohorts / female _ cohort. And then we'll need a list of field names. So if you, basically we provide a lot of recipes for kind of querying the field names for entities. So if you only know kind of the beginning of the field name, or you only have the field title, we give you some recipes for basically searching for that programmatically. But we need this list of field names to basically access the fields with the DX data package. In our case, we also want to return the participant IDs or the EIDs as well.
Can I ask more about the cohort step? So
Sure.
if I'm just starting with querying and I actually do not have any cohort created, could I just omit this step and do all that you're showing? Will it affect it somehow?
Yes. So if you need to retrieve everything for the particular data set, just keep in mind this is a very large retrieval. So it's over 500,000 participants. You can omit this step, and I'll show you where you basically omit this input in the next step.
Okay, thank you.
So now we've kind of set the stage. We've got our list of field names. We've got our participant entity, and we have our cohort. So now we're able to basically start extracting our fields as a Spark data frame. So let's kind of go through these different arguments just so you understand where they come from. So the first thing we'll do is we'll provide our list of field names here that we defined in step 5. So we are going to be utilizing, there is this filter underscore SQL argument here. And you can use it in, basically we're going to plug in this property of our cohort that we've just retrieved, which is the .SQL property here. And this is a little bit of Spark SQL code that basically filters the retrieval down to that particular cohort. So if you are, this is optional. So if you want to retrieve everything for the data set, you can just remove this particular argument. And there are 2 other arguments. So the first is we want the actual values, including our categorical values. So we're going to set this coding underscore value argument to replace. And then this last argument is always going to be the same. So engine is equal to dxdata.connect. And then don't forget the parentheses at the end. So when we basically retrieve use retrieve fields, this is basically in a Spark data frame format. So we are going to then convert it to a pandas data frame. Now that we've done kind of everything we want to do with the Spark data frame. So we can use this toPandas method built into the Spark from PySpark to convert it into a pandas data frame. And here you can see that we have retrieved all of our fields that we're interested in, including our field ID or our participant ID, our gender, and then our other measurements.
I would like to ask more about how to transform from Spark to Pandas. So if I understand it correctly, once we retrieve data, we have a Spark data frame. Yep. And now you're converting it to Pandas. Do you have any recommendations? When should we move from Spark to Pandas? Or should we ever want to move?
Yeah, so again, like a lot of the filtering commands and everything, if you're comfortable with Pandas, you can convert to Pandas as soon as possible. Just be aware that if you're retrieving like hundreds of fields for all of the data sets, that may not be able to kind of fit into memory. So you want to try to retrieve like, a set of fields for a cohort rather than doing that. But if you have like, 10 or 15 covariates that you want to retrieve, that should be fine.
Okay, thank you.
So now that we've got our data frame in pandas format, we can use that to_CSV function or method to convert it, to save it as a CSV file. So we're going to save our pandas data frame as female_cohort_covariates.csv. We'll use a cell magic to basically get this from the Jupyter instance storage into our project storage. And we'll save it into our cohorts folder in the project. So now that that is done, we can go and do downstream analysis. So I'm going to go through this a little quickly because I want to get into the demo and I want to have time for questions. The main thing to keep in mind is that when you're working with Spark data frames, like again, you can use kind of the full memory and CPUs of the full Spark cluster. You're going to be using PySpark commands for manipulating and querying. If you need to do machine learning and statistical modeling, there is an additional library called MLlib. When you're working with Pandas data frames, you'll be using kind of the kind of normal methods and libraries that you're familiar with. So Pandas, NumPy, and scikit. So again, I just want to point out that there is like more information that we can cover in today's demo in the JupyterLab notebook, but there are a lot of recipes that are very useful. So for finding field names, finding from titles like partial titles, or if you want to select all of the instance and arrays associated with a particular field, we have recipes for that. Working with the codings, and then doing filtering and cohort refinement with Spark using PySpark. And again, all of this info is going to be available in this notebook. So again, these slides are going to be available to you, but we just want to give you a quick kind of recipe for accessing the demo notebook. So again, this is in GitHub, sorry. And then, so what you can do is you can basically clone that repository directly into your JupyterLab instance storage. So the first thing you need to do is open a terminal window. And then you can use in the terminal, you can use a git clone for the repository to basically clone all of this into your JupyterLab instance storage. When you're done, just don't forget to upload the notebook back into your project storage if you made any changes to it. So I'm going to skip over this slide so we can basically get into the demo. So let's get into the demo and start kind of working with our data set. Okay. So let's kind of talk about, we talked about kind of the general process. So this is just basically reiterating the things that we need to basically start working with the pheno data. And we're going to go through each of these steps of the process. So the first is to run the prologue. And again, this prologue is going to be the same for every time you kind of connect to the pheno data. So the first thing we're going to do is basically import the packages that we need. So I'm going to show you what happens. So you only want to run this code block once. I'm going to show you what happens if you run it twice, and I'll show you how to fix it. So like, you know, if this happens to you, and it has happened to me, I'll show you how to basically recover from it. So we're going to connect to our Spark cluster. You can see that we are busy. So I'm going to accidentally click on this twice. You can see we have this error, Spark is mad at us, but that's okay. So we can actually basically restart our kernel and recover from this error. So if we go into the kernel menu and we click Restart Kernel, we can click Restart, and we can start re-executing our code blocks again. So I'm just going to run these two code blocks, and again, running this one only once. And then again, this code is always going to be the same. So this is basically going to find the particular dataset ID that is associated with your application. So I just want to show you what that dataset ID looks like. You can see it has this kind of record And this is basically, this is kind of special data type on the platform, but this is what you need to actually connect to the particular data set. So now we can access the data set using this load_dataset method by passing in that dispensed dataset ID. So now I want to show you some particular entities, which are virtual tables that are linked to an. So these are those kinds of virtual tables that we're talking about. So let's look at all of the entities that are kind of available for our data set. So in our case, you can see that there are kind of 3 entities. This is a demonstration, so this is not the entities that are available to you are going to be different, but you can see we have a participant entity, a death entity, and a death cause entity here. But the one entity that we are interested in is a participant entity. So I'll access that using our bracket accessor. So you can see we have bracket, and then we put participant in quotes, so we can access the participant data structure. So now we have that, we need to get, remember that other piece of information that we need is our cohort information. So we can use this load_cohort method with the path to our cohort. Oh, apologies, I need to fix this. Just a quick. So our cohorts and that we want to access is this one called nervous system. You'll see Spark was processing that. So again, this is another thing that we're going to input into our retrieve fields method is this .sql property. And if you run that, you can see this is basically all of the filtering that we did to basically produce this cohort in Spark SQL format. So here we have a list of field names. So we have exact field name matches, but I'll show you in the later part of the notebook exactly how to work with field names and retrieve them. So here, basically, this is our list of field names we want to retrieve. So now we have all of the pieces we need to basically retrieve the fields that we want as a Spark data frame. So this is basically, we're going to be using retrieve fields here. And basically you can see that we are doing this on our participant entity. So that was one of the pieces of information that we needed. We have our list of field names, and then we have our filter SQL for our cohort. So let's change this. Okay, apologies. This is a different project, but at least I have the output to show you. So this is actually this is synthetic data because we don't want to actually expose any EIDs or information about participants. But you can see that we have retrieved our information that we want, including our gender here. And if we want to know how big our cohort is, we can use this 39. We can use this .count method. And you can see it has, our cohort has about 39,000 in that. So now that we have our data frame, we can convert it into a pandas data frame using the toPandas method. So again, remember our DF object here that we've created is a Spark data frame. So we can convert it to a pandas data frame. And you can see that we have our particular, that we returned the data frame into this pandas format. So then we're able to basically convert our pandas data frame into a CSV file using that toCSV method, and then upload it back into our UKB project using DX upload. Again, this notebook is, this new version of the notebook will be sent out to you, so you will be able to kind of work with it. So I just want to finish by talking about the different skills or recipes. So for example, so if you have a list of fields by ID and you don't know if there's instances or arrays with them, these are a couple of functions that we've written for you that basically let you kind of retrieve all the field names for a particular UK Biobank field ID. So you can see that this is this function here. So if you just have the use the kind of beginning field ID without the P, you can use this field underscore names underscore for ID and then pass in 31 and it will get you the actual field ID. This is for retrieving multiple instances for a particular ID and arrays. There's some additional functions here for retrieving fields by title. And then there is an additional kind of set of skill recipes for working with Spark. We can only show you kind of the basics, but doing some filtering using Spark can be very helpful. So let's just kind of wrap things up and there'll be 5 minutes for questions. So let's talk about downstream analyses that you can do with Spark once you've kind of created your Spark data frame. So basically, you can start doing things like GWAS using Hail or Glow. Again, these are Spark-enabled libraries. And this, so the whole exome data is going to be available as a matrix table, hopefully soon. It's in the pipeline. The machine learning, you can also do machine learning using Spark MLlib. I think we went over most of these. Just really want to emphasize that DX data is that main method for which you're accessing the wrap data set, and that you're going to be using the retrieve fields method. That's going to be your main method to get data out of the data set as a Spark or Pandas data frame. Again, just want to kind of wrap up. That was pun not intended. So what are the next steps? Again, so here's a quick start. If you haven't signed up or dispensed your project, link to the newsletter and example notebooks. And again, we want to encourage you to ask questions in community. We're all learners here, so don't feel reluctant to kind of reach out. We all kind of start somewhere. So let's just let's see if there are any questions that I need to answer. Anastasia, were there any kind of pressing questions?
Well, there are 2 questions that are a bit advanced that we're working on, but basically there was a question about differences between normal JupyterLab and Spark JupyterLab, and normal meaning like single node JupyterLab. So just to emphasize that if you want to query data, then you need to use Spark JupyterLab that Ted was just talking about. In case you have data extracted by someone or you extracted it either by Spark JupyterLab or using table exporter, then you can use normal single node JupyterLab.
Yeah, and just a note, so DX DX Data, the use case is really for Spark JupyterLab. We've had this question before, whether you can kind of install it on your own machine. And it's only kind of usable under very special circumstances, and it is mostly supported for use in Spark JupyterLab. Hopefully that answered your question. So there's one question from Daniel. Can we make our own Spark objects? So yes, Daniel, you are able to. It does take a little bit extra work to do that. So you'll need to be able to get your files onto the Spark JupyterLab, and then you will need to kind of transfer that over into the Hadoop file system for the Spark cluster using HDFS. If you're interested in that, please reach out to support and we can let you know about that.
Ted, there was one more question in the chat. I'm sorry, I think I was sending people reminders, but it was to the hosts and panelists. So the question was, do I need to know Python to use Spark Jupyter?
Yeah, so very good question. So so for working with DX Data, yes, you need to know at least a little bit of Python, what we've shown you, to basically work with the Spark JupyterLab cluster and the data set. Is it possible to connect? Okay, so there is another related question. Is there possible to connect to wrap data sets in other ways in local Python code? Unfortunately, well, not unfortunately, I mean, this is kind of the way it is. It's basically DX Data is really kind of the method to connect with it. And, you know, if you need to, you will need to retrieve the data either with Table Exporter or with Spark JupyterLab. So there is a question from Santiago. Is there going to be a webinar about genomic, that is whole exome sequencing data analysis? I think it would be very useful. Thanks. So we are having a GWAS seminar that is coming up next week. Sorry if I forgot to announce it. That information, if you're on our mailing list, will be sent out, and it'll also be available in community.dnanexus.com.